Okay, the reason why this is, when you looked it up, is called section 4.4a is because we're splitting up section 4 into two sections. This section will only cover page 180 and 181. There'll be 4 skills for factoring polynomials you're going to have to learn. So here we go. Example 1, you'll notice it's got 3 parts. All use a very similar skill, but then not only do you have to learn this new little bit, but you got to remember your old stuff for factoring quadratics. That's the key, is to get things simplified down to where you're looking at a quadratic. And then you use your skills for factoring quadratics. If you're not very good at that yet, you will be before you're done. So the very first example is, it says factor each polynomial completely. You need to find all the factors possible. We got x cubed minus 4x squared minus 5x. And we're just factoring. We're not solving anything. We're just practicing the idea of busting this down into factors. The first thing you should always do in any factoring situation, and it hasn't really been driven into your mind this year to do this, because most of what they give you doesn't have this first step, but really and truly, every time you factor anything, you should always, first thing, look for anything that all the terms have that you can divide out. And every single one of these terms, if I'd written it right, every single one of these terms has an x in it. So we need to divide that out. In other words, use distributive property in reverse. We need to yank an x out of there, and that will leave us x squared in this term, negative 4x in this term, and negative 5 in this term. Anybody have any trouble with that? Okay, so now when we yanked in this case, when we took the x out, what remained after we took it out was quadratic. And so you use your quadratic factoring skills to finish it. Yeah, 5 and 1. I need factors of 5, because this is a 1 now. Remember, it was a 1 up here too, but it's a 1 here on this quadratic, so I need factors of 5 that subtract to be 4. And you're right, 5 and 1 is our only option, and thank goodness they subtract to be 4. To get it to be a negative 4, though, of these two numbers, the 5 has to be the negative and the 1 the positive. Does that make sense to you? Okay, that one's done. That's just your very first taste of your very first skills, so don't get too comfortable yet. Okay. The next one, the B part, says 3y to the 5th minus 48y cubed. 3y to the 5th minus 48y cubed. And again, you should always start any factoring issue by figuring out if there's anything you can take out. Anything that both terms have that you can divide out and take it out front. Does 3 go into 48?
Yep.
How do you know?
4 plus 8 is 12.
Excellent. 4 plus 8 is 12, which is divisible by 3. So we know we can take a 3 out. What else? Anything? A y cubed? A y cubed. So we can take out a 3 and a y cubed out of both of them. What remains in this one? Okay. What remains in this one?
12, 16.
Which one?
16.
Positive or negative? Negative. And there's no y's left? Or are there? No, they all got divided out because there was 3 of them there. And take a look at what you've got left now. You have to remember this little skill from quadratics too. This is a difference, because it's a minus, of 2 squares. See, the 16 is a square? And remember how they factor. They factor into conjugate pairs, we call them. Y minus 4 and y plus 4. And it doesn't matter which one goes first. And then the 3y cubed just come along with everything too, so that this is completely factored. So a difference of 2 squares, you have to be able to recognize that. It always factors into a conjugate pair, meaning they're exactly the same except for the sign. Difference of 2 squares factors that way, because it's the difference in sign that makes that middle term, the y term that's normally in a quadratic, it makes it add out. Look, we got y squared. This would be 4y minus 4y. The y's are gone, minus 16. So that's the reason why there's no y term in here, because the conjugate pair causes that to happen. They add out. Everybody clear? Yeah. So we're okay on the first 2? You had to remember quadratic factoring skills once you got it down to a quadratic. This was a quadratic of a special type that factors a special way. You have to remember those. You still got to rely on those. The next one is 5z to the 4th plus 30z cubed plus 45z squared. And if you're following what I've asked you to do so far, you look for anything that they both have, that all 3 has, that we can divide out. How do you know 5 will go into everything?
They're all divisible by 5.
Well, how do you know? I mean, here you knew this one was divisible by 3, you had a rule. Why are these all divisible by 5? Yeah, because they all end in 5 or 0. That's how you decided 5 will go into it. Excellent. I just wanted to know if you knew. Okay. So I take a 5 out. Is there anything else? Z squared. What remains in this term?
Z squared.
Good.
Plus 3.
Plus
6.
6 Z, because I took out 2 of them. There's 1 left. Plus 9. Oh, amazing. Not only is this thing factorable, it's a perfect squared trinomial. Remember how you tell that? If this is a 1, then if half of this squared is this, it's a perfect squared trinomial. Remember? So it's going to factor like this, if you remember. It'll be Z plus 3 twice. That's how you should write it. Does that make sense to you or not? Okay, so far so good. And in each case, we had to remember a little bit about another quadratic skill. But the main thing on this, so that's number 1 of the 4 you have to take a look at. That's uses the skill of factoring out what's common and factoring the remaining quadratic. Okay, so that's 1 skill. The next one is one you've never seen before, and I would highly, highly recommend that you put down at least 1 example maybe in the margin of your paper so that you can refer back to it without having to look it up. In the middle one that I just erased up here, if you'll remember, we factored a difference of 2 squares by writing Z plus 4 and Z minus 4, do you remember? Well, there's also a rule for factoring a sum, meaning addition, or a difference, subtraction, of 2 perfect cubes. Now, do you know your perfect cubes? I'm going to make a list of this too. You might want to put this down on the left side of your paper. It's a list, and I'm going to make it vertical. 1 cubed is 1, because it's 1 times 1 times 1. 2 cubed, which is 2 times 2 times 2, is 8, not 6, 8. 2 times 2 is 4 times 2 is 8. Anybody know what 3 cubed is? 27. Good. 4?
64.
Good. Excellent. 5?
125.
Good. 6? 216. 7? 343. 8? 512. 9? 729. 10, and it won't get much bigger than this, I wouldn't think. That's 1,000. The reason why it's kind of handy to have these written is because if you suspect that it's a perfect cube, you can look over here in this list and see what it is. Not only that, you can tell what is the perfect cube of, because you're going to need to know that as well. So these are your first 10 perfect cubes. So if you recognize those numbers when you see them and suspect that they might be a cube, you could either ask your calculator or look in this list or whatever. But you need to be aware of these about this many perfect cubes in order to be able to do what we're about to do. Now, I will bring it all together. It's kind of like the other day when I had Pascal's triangle and I had the binomial theorem and all that stuff, and I tied it together. Just give me a minute. I will tie it together for you. In a general way, this is the thing you might want to put at the top in your margin and then perhaps an example to go with it. But here's the deal. If you have something cubed minus something else cubed, it might be x cubed minus 8 or 8x cubed plus 343. It involves cubes, and there's only 2 of them. Whether it's a sum or a difference doesn't matter. I'll do the sum one in just a minute. This factors this way, and there's only, I was thinking last night, I was trying to go to sleep, there's about only 2 things in algebra, high school algebra, that you just flat out have to memorize. It doesn't make sense. It's not something you can reason through and refigure and try to figure it out. If you don't have this memorized, you will not be able to do it. All I can tell you is it works. I can show you that it works, but there's no good reason for reasoning through and saying, well, if I did this and this and this, then I'm sure that this would be the case. This is a memorized thing. I'm sorry. It is one of each of these. So you cube root both of these and you write the cube root of this one here and the cube root of this one here, and you use the same sign. So if this was x cubed and this was 8, you would put x here and 2 here. Does that make any sense? Some of you are just looking at me. Nod your head a little bit. Just give me some indication. If this were an x cubed and this were an 8, the number 8, then I would put one of those 3 x's here and one of those 3 2's here.
Okay.
You with me?
Yeah.
Then, if you follow what I'm telling you, the memorization will be easier. Then you don't look at this anymore. Once you get these two numbers cube rooted, don't look at this anymore. Look at this. The next part is a trinomial, and it's made up of these, the way you memorize it. It's the thing that you wrote here squared, so that you can get this times this gives you that a cubed back, right? Got to leave.
Squared, yeah, you wrote cubed.
See, that's what I get for talking while I'm writing. Yes, squared. Because I was thinking of what I was going to tell you, which is this times this is a cube. Okay, so you got to have this, whatever this was here, you got to have it squared here, so that when you were to multiply it back out, you can get your a cubed back. You see what I mean? Okay. Then, whatever sign this had, which is the same as this one, you change it here. So if this were a plus, this would be a plus, and this next one would be a minus, but it's not. This was a minus, this is a minus, this one right here, following this first letter here, is the opposite of what you wrote here. Then, the middle term is, we're looking at this again, it is this front one times this back one. Ignore the sign. Ignore the sign. You've already built in a sign right there. But it's whatever this number is times this one goes in the middle. It's not times 2. That's a different thing. That's when you're squaring a binomial. It's not it. It's just this times this goes in the middle. And on the back, and it's always positive no matter what, is this one squared. Because again, you got to be able to take this times this and get this back. And this is always positive. So if you do it with a sum of 2 cubes like this, then it's one of each, plus again, those two match. And then it's just like this, only the second sign will change from what this one was. So it will be a squared minus ab. And this one's always plus on the back, b squared. So it's a binomial and a trinomial. And the binomial is one of each of these, same sign. And the trinomial is built off of this in a pattern. This squared on the front, this times this in the middle, this squared on the back. These two signs change. You got to remember that. So it's kind of weird when you see them lumped together. If you were to lump these together into a single thing, this is what it would look like. I just want you to be able to read the signs. If it were a cubed plus or minus b cubed, it means either one, then it would factor into a plus or minus b in the same order. So it's plus minus here. And then this would be a squared minus plus. See how that switches the sign on you? That's a switch, that's a sign switcher. So if it was plus, it goes to minus. If it was minus, it goes to plus. AB, and then always plus b squared. So that's a summary of both of them together, if you want. So let me show you like 3 or 4 examples of this in specific examples. Then I'm going to turn you loose and try have you do one, at least one. So here's a very simple one. I'll do the one I mentioned before. So these are the rules, and I'm going to do x cubed plus 8. That factors like this, x plus 2. Y'all see where I got that? Cube root of x cubed is x. Cube root of 8 is 2. One of each of those that were cubed here. And they're not always going to slap a cube on it for you. So that's why you have to recognize what you've got, and then you write one of those things that was cubed to make this. Then don't look at this anymore now. Just look at this. It's going to be x squared minus 2x plus 4. You buy that? Yeah. Okay, now listen. There's something I didn't tell you. Something I didn't tell you when I was telling you about the generalized thing up there. This trinomial, while it is quadratic, you'll have to trust me on this. This will never, in this situation when you're doing cubes, this part will never factor further. You don't have to try. Not only that, if you did use the quadratic formula on this piece of it, would always return imaginary solutions. So you need not try to factor this. You can trust me on that. That won't factor ever in this situation where you're factoring cubes. So you have a binomial and a trinomial and you're done. You gotta memorize the pattern. So let's try this one. What if I had, for example, 2x to the 6th minus 54. That's kind of throwing you in the water, hoping you can swim kind of thing. That's kind of rough. You're going, that's not, neither 2 or 54 is a perfect cube. That's why you take it out. That's what we learned prior to this. So before we start trying to factor this, we should take out a 2, because these are both even. That's how you decide if 2 will go into them, right? And what are you left with? X to the 6th. 27. And then you say, oh, that's a perfect cube. I recognize that from my list, but that isn't. Yes, it is. It is x squared cubed.
Oh, wait a minute.
So if your exponent is a multiple of 3, you've got a perfect cube here. So to finish factoring this, part of it, well, I'll just carry it on over. It's going to have a 2 in it. Just ignore that. We took that out. That's just going to tag along to the problem. And then it's one of these, which is actually x squared minus 3. See it?
Yeah.
Times this squared. What is this squared? X to the 4th plus 9. No, 3x squared. 3x squared. This times this.
And then plus 9.
Then plus 9, yes. So that's pretty wild one. Pretty crazy. Do you want to see another one or do you want to try one?
Let's try one.
You want to try one? Okay.
Sure.
All right, then I'll put it up here in red to distinguish. Well, I'll put it in blue. Try this problem. 3x cubed plus 375. One of the reasons I'm having you do this is so that if you run into trouble, I can come to you specifically and help you with your individual problem. So if you're struggling, please let me know some way or another and I'll come see you. We'll work it out. Get it? Good. We should have done that. Oh, yeah, we'll do that. Look there, that list. Be sure you have 3 to the end because it's hard.
Okay.
Yes. As is those triangles. Square this on the front. Take this times this in the middle, and then negative sign.
Square 5.
Keep your eyes on place.
Can I help anyone else finish it? Okay, it should this. Know what you got? Okay, now let me just, before I leave this little skill that we've learned, this is your second skill. Okay, here's the big deal. You need to count how many terms the thing has that you're trying to factor. If it has 3 terms, it's quite likely you will use your quadratic factoring skills, where you do 2 binomials, because it's got 3 terms, it's got an x squared term, an x term, and a constant. You find factors of the back that add up to the middle. Sometimes you have to combine it with something in front if it doesn't factor out or something. So if it has 3 terms, go back to your quadratic factoring skills. If it has two terms, like this, and like this, and like this, and possibly like this. If it has 2 terms, it's either going to factor as a difference of 2 squares or as a sum or difference of 2 cubes. The key to which one you're going to use is the power on this number. If that is a multiple of 2, perhaps it's a difference of 2 squares. But if it's a multiple of 3, probably a sum or difference of cubes. But if it has 2 terms, it'll be one of these 3 situations, either perfect or difference of squares or sum or difference of cubes. And you have to remember both sets of skills. Like, for example, this one factors into a conjugate pair. We deal with squares, not cubes. So if it's a difference of 2 squares, it factors into a conjugate pair where you're dealing with square roots. If it's a sum or difference of cubes, you're dealing with cube roots. The list over there. But both cases have 2 terms to start with. Two terms. That'll narrow down your strategies to one of 2 things. Difference of squares, difference of cubes. Sum or difference of cubes. If it has 2 terms. If it has 3 terms, like the ones that I erased before we started this skill, where it's got a squared term and a single and a linear term in the middle and a constant, it's got 3 terms, you're gonna have to fall back to put down your 2 sets of parentheses, split up your x's, figure out factors of the back that go in the back, you know what I'm saying? Those skills. If it has 3 terms. It's quite possible that what you have to factor has 4 terms. And if it has 4 terms, there is only one method. So you gotta categorize these things in your mind. If it has 3 terms, I've got these things I can apply to it. If it's got 2 terms, it's either that one or this one. If it's got 4 terms. I'm teaching you your 3rd skill now. If it has 4 terms, it's called factoring by grouping. I'll show you that one next. But this factoring by grouping skill only applies if there are 4 terms to start with. And even then, sometimes it doesn't work, but it's the only thing that you can try. And if it doesn't work, then you're just stuck with it without factoring. Chances are, because this is a lesson on factoring, that if you run into a 4-termer, it will factor. They designed it to factor. It will factor in this way. I'm going to show you. So I've got z cubed plus 5z squared. I'm doing example 3, by the way. Z cubed plus 5z squared minus 4z minus 20. So this is your first crack at trying to do not a quadratic, but a cubic function. It's got 4 terms. And since it has 4, all the skills you've learned up to this point today don't apply because it has 4 terms. Factoring by grouping requires you to look at the first 2. This is the grouping part. And ignore the back 2 entirely. Just forget them. Just look at the first 2 and pretend these are not even here. And look at these first 2 terms and tell me if there's anything you can take out.
Z squared.
Okay, so we're factor by grouping. As z squared comes out, what remains in these 2?
Z plus 5.
Good. Now, we leave that sitting there, and we now focus on the back 2. We're grouping our concentration on that. And we look at the back 2, just those 2, pretend there's nothing else here, and tell me, is there anything common to those 2 things?
4.
If I take out a negative 4, what remains? Be careful now. Z plus 5, because we took that negative out with the 4. Are you with me or not?
I'm with
Okay, if you write it this way and you write out what you factored here, we'll give the appropriate sign here. What's happened, folks, is we've gone from 1, 2, 3, 4 terms. We've actually gone to where there are only 2 terms. Now we look at that, these 2 terms together, the whole thing together. I'm just saying, these are the 2 terms you got. You're going, no, sir, because there's a term. No, these parentheses, when you put parentheses around them, they act like it's just one idea. So this is z squared times an idea minus 4 times an idea. But the ideas are the same. Which means that of these 2 terms, we can take out those, the same term out front, just like we did the z squared out of there and the negative 4 out of here. We can take this is what's common to both of them, out front. We have z plus 5. That's what they both have. And what remains is z squared minus 4. Do you see it? So we've gone from 4 to 2 to 1. And you have to look at the pieces of the one that remains and see if it could be factored further. Difference? Squares. Which means we can go a step further. Z plus 5 times, z minus 2, z plus 2. Because that's a difference of 2 squares. They factor as conjugate pairs. Did you follow that? Any questions? Let's try another one, and then I'll let you try one. And then we have to get one off of the exercises. How about we do one that you're assigned? That'd be good, huh? Let's do number 25. 3a cubed plus 18a squared plus 88 plus 48. Okay, now I want you to notice why when I turn to the exercises, I quickly, and I mean quickly, scan through to try to find this. I want you to look at the exercises with me for just a minute before we tackle this. Look at page 184. What do you suppose I was looking for when I was trying to find a problem that I could demonstrate like this? Every one of the exercises says factor the polynomial. What do you suppose I was looking for to demonstrate this skill again? Ones with 4 terms, people. 4 terms use this skill. Look. I scanned quickly. 5 through 12, they all have either 2 or 3 terms. 13 has either, just 2. 23, oh, there's 4. That's where that set is. That's what I was scanning for. That's what you should do too. If there are 4 terms, you narrow down your skill set to saying, oh, I handled 4 termers by grouping. So I was looking for 4 terms. Notice that I did not find any more of those in 31 to 38. Those are all 2 or 3. And you can scan quickly. Okay? So I was looking for 4 termers, and I found one. There's still others that you have to do, but this is a 4-termer. How will I begin on this one? Anybody have any idea? Factor out what? 3a squared. And what remains?
A plus 6.
What do we expect to remain when we get done factoring that one? A plus 6. Do we get that? What's common to these 2? Positive or negative? I already gave it away. What's left?
A plus 6.
Yeah. And if it's going to work all the way through, then what remains here and what remains here better be the same. Because the next step now is to factor these 2 terms, and they both have an a plus 6, which I yank out by dividing. What remains?
3a squared plus 8.
3a squared plus 8. This is linear, so it's not going to factor any further because it's got a 1 there. Will this factor further? Is that a sum of?
Yes.
First of all, it's a sum, so it can't be a difference of 2 squares like it was over here. It can't be that because it's a sum. I don't care if these are perfect squares. If this is a plus sign, you cannot factor it. Is it a sum of 2 cubes?
No.
Where does it fail to be a sum of 2 cubes?
8.
The 3, not the 8. The 8's a cube.
Well,
The 3 isn't. And you can't pull that out. 3 doesn't come out of 8. This is done. It's a sum, and this is a cube, but this is not. First of all, it's a squared, not a cubed, and 3 is not a cube. So you're done. But you gotta look. You gotta look. Do you see what I'm saying? All right. That was number 25, which is part of your assignment. If you want to write that down, you can, or just do it again when you get it. In order to practice, I would like you guys to try number 30. You guys do number 30. I'll write it on the board so that we can work on it together in a minute, but you try number 30. Looks like this. This one's got a little bit of a quirk to it, but maybe you can figure it out. Let's give it a try. If you need some help, speak up. This one's got a few issues to it, that's for sure. Things you have to sit and think about. Because one is what we square one. Help anyone else? Does anyone need more time? You should have 3 factors at the end. Not just 2, 3. I'll show you how it shakes out in case you didn't get that. Most of you did really well, but better than I expected with factoring this part right here. This is going to be, take a 16 out and an n squared, and what you have left is n in this term. Took a 6, divided a 16 out of here, you got a 2. You took all the n's out, so it's just plus 2. Then this back here, these 2 terms, when you're factoring these by grouping, they actually have both share a negative sign, or a negative 1. And what remains is a positive n and a positive 2. Does that make good sense? Most of you were able to get that far, okay. So now you have 2 terms, and they each have an n plus 2. So you take the n plus 2 out, and what you have left is, and this can get some people a little bit, What you have left is 16n squared in this term, this guy. But then you also have a minus 1. You have to have a minus 1 because if you take all of a term out, you have to have a 1 to hold its place, just in case you decide to redistribute. I'm going to take this times 16n squared, so get this back. But you got to have a 1 there so that when you take this times this, you can get this back. You got to have a 1. You see, it doesn't just disappear. And then the thing to notice is, this one is linear, so it can't factor further, but this one is a difference of 2 squares. 1 is the perfect square of 1. 16 is the perfect square of 4, and n squared is the perfect square of n. So this is a difference of 2 squares. So it should factor all together. I mean, when it's all done like this. Square root of that is 4n plus 1, because the square root of 1 is 1, and 4n minus 1. That was a difference of 2 squares, which factors into conjugate pairs. See it?
Yeah.
That's kind of an odd difference of 2 squares, but it is a difference, and it's of 2 squares, so you have to split it up by square rooting. Plus and minus was a conjugate pair. Now everything's linear. Now it's all done. Now this one couldn't go any further because it wasn't a sum or difference of cubes. It wasn't a difference of squares. This one was. And if it is, you got to take it a step further. Finish it off. Do you all see that? Okay. That's the third skill. Factoring by grouping if there are 4 terms to start with. The last skill is actually a skill you already have. You just haven't applied it this way. The last skill is using quadratic factoring techniques to factor polynomials that are quadratic-ish. I'm about to tell you what quadratic-ish means. When you have just a typical quadratic like this one, let me just write one up here. N squared plus 2n minus 4. That's a quadratic. And what you've learned about quadratics is when you put it in standard form is to put the squared term on the front, then put the linear term or the power of one term next if there is one, and then the constant. That's how you put it in standard form, right? But here's something you may not have noticed because you haven't had anything to compare it to. That's fine. Is that this power right here, too, half of it is 1. So half of this is 1, and then we have a constant. What I'm telling you is that this right here, n to the 6th plus 2n to the 3rd minus 4 is not quadratic. But it is quadratic-ish because the highest power cut in half is the next power, followed by a constant, and it has 3 terms. This is not quadratic. But because of this pattern in it, it's quadratic-ish. This, half of this, when it's in standard form, half of this is the power on the next term, followed by a constant. And if that's the pattern, then this is quadratic-ish and can be handled like a quadratic. Now, this was a poor example because this won't factor. I just wanted to show you how you recognize quadratic-ish things. So let me give you an example of a quadratic-ish thing and how you can apply quadratic skills to it. Let's take 3p to the 8th plus, wow, they're really throwing a hardball at you here. 3p to the 8th plus 15p to the 5th plus 18p squared. Let's take a look. 3p to the 8th plus 15p to the 5th plus 18p squared. Our task is to factor that. And you might think, well, wait a second, Mr. You just said that if whatever this is, if half of it is the next one, then I've got a quadratic-ish. But it isn't, because half of 8 is 4, not 5. But what have we not done?
Taking stuff out.
Taken out what's common first before we make that analysis. What could we take out of this thing? All of these have a what? A 3 and a p squared. What remains? P to the 6th.
Plus 5.
P to the 3rd, because we took 2 of them out. Plus 6. We took all of the p's out of that one. Now, what remains is quadratic-ish. Do you see it? Because half of this is this followed by a constant. So it's not quadratic. but it can be handled like a quadratic, and this is what I mean by handled. When you have a quadratic, what you usually do is you take out what you can first, and then you slap down 2 sets of parentheses, and you split this up in the front as p cubed and p cubed, instead of just p and p. Are you with me? Then you do the very same thing. These are your skills. There's a 1 right here, so you can take factors of 6 that add up, not subtract, because this is a tricky one. There are factors of 6 that subtract to be 5, but there's also factors of 6 that add up to 5, so you pay attention to that sign very carefully. Factors of 6 that add up to 5, what are they? 2 and 3, not 6 and 1, 2 and 3, because they got to add up to 5. Since it's a positive 5 right here, these are pluses. Then you got to look really carefully at what remains. These are perfect cubes, but these are not. So you can't go any farther. But if this were an 8 and or this were a 64, then you would have to follow the pattern for cubes. But these are not cubes, so you're done. But if they were, you'd have to continue with the factoring pattern I taught you about, sums and differences of cubes. You see what I'm saying? So this one's finished. And this was quadratic-ish. After we factored it out, it's quadratic-ish, meaning half of this is this, and then followed by a constant. And so you split this up right down the middle. So if this is 6, you get 3 and 3. If that were 10, you get 5 and 5. And then you follow your quadratic skills by taking factors of this that do this to make this. And if there's a number in front of here that didn't factor out, then you're going to have to follow those skills where you take this plus this or whatever to get this in the middle. Got to use your quadratic skills on a quadratic-ish thing. Here's another quadratic-ish thing. 16x to the 4th minus 81. 16x to the 4th minus 81. This is not a quadratic equation. But it's quadratic-ish because this is a difference of 2 squares. Which factors like this? We write down our 2 sets of parentheses, and it's going to be a conjugate pair. It's going to be the square root of this, and the square root of this. I mean, the other square root over here. The square root of that goes here, and here. And it's a conjugate pair, because that's how you factor sums and differences of squares. Even though it wasn't a quadratic, it was quadratic-ish, because it was a difference of squares. And then you look at what remains and ask, could I factor it any further? This is a sum of squares, so I don't have to look any farther. It's not cubes. But this is a difference of 2 squares. Again. So this can't factor because it's a sum of squares. We can't do that. 4x squared plus 9, and this factors into 2x plus 3 and 2x minus 3 because it was a difference of squares again.
So you can't go any further when it's a...
When it's a sum of 2 squares, you cannot factor it anymore. The reason why is because when you multiply these conjugate pairs, that's what gives you the negative 9 is the fact that these differ in a sign. And it's the difference in sign that makes the middle term add out. So this doesn't have a middle term. But you can't possibly get the middle term to add out and still get a positive number back here because you'd have to have both the same number here. That can't happen when they add out. So this is impossible to factor over the reals. You could do it over the imaginaries, but we'll have to be doing that today. We'll stop when it's stuck at the reals. Do you think you can swing this?
Yeah.
Okay. The first assignment, if you're doing it on paper, is this is 4.4a. Put that in the top of your paper. It's just the first half of this. And it is number 2 and 5 to 37 odd. 2 and 5 to 37 odd. You got a good chunk of time to get this started. If you don't waste your time, you might be able to get the help you need to get this finished. So good luck with that, and we will do the second half tomorrow, which is sort of related, but not really.
What percent do we need to get an assignment?
90 or better. If you have an 89 point something enough to round it up to 90, it's okay. Okay. All right, that's the end of it. See you guys.